In the Solve It, you may have used reasoning to find the amount of money in the chest. In this lesson, you will learn to solve this type of problem by using equations. Equivalent equations are equations that have the same solution or solutions. Take note. Property. Addition and subtraction properties of equality. First, the addition property of equality. Adding the same number to each side of an equation produces an equivalent equation. In terms of algebra, we can state for any real numbers a, b, and c, if a equals b, then a plus c equals b plus c. An example, x equals 4, so x plus 3 equals 4 plus 3. The subtraction property of equality. Subtracting the same number from each side of an equation produces an equivalent equation. In terms of algebra, we can state for any real numbers a, b, and c, if a equals b, then a minus c equals b minus c. An example, x plus 5 equals 7, so x plus 5 minus 2 equals 7 minus 2. Here's a scale to demonstrate the addition property of equality. We have a balance established, so we can see that x, shown here on the left, some unknown quantity, equals 4. We have 4 unit blocks on the right-hand side. X equals 4. X plus 3 does not equal 4. In the scale example, x plus 3 has a greater mass, so it's tipping the scale. But if we add 3 more, we attain balance or equality again, an example of the addition property of equality. In this case, the equation could be modeled x plus 3 equals 4 plus 3. The subtraction property of equality. First, beginning with balance, x plus 5 on the left equals 7 units shown on the right. If we subtract from the left, it looks as though we've subtracted 2 single units. Now we don't have balance anymore. However, if we subtract 2 units from the right, now we have balance once again. And as an equation, we could represent that x plus 5 minus 2 equals 7 minus 2, the subtraction property of equality. To solve an equation, you must isolate the variable. You do this by getting the variable with a coefficient of 1 alone on one side of the equation. When a variable has a coefficient of 1, you do not have to write the 1. 3 examples. First, x equals 6. Is the x isolated? Yes, the x is isolated. It's all by itself, and it has a coefficient of 1. We don't write the 1, as mentioned in the last slide. It's a more simple form to not write the 1 and only write x. Next, p plus 5 equals 8. Is it isolated? No, we have the plus 5. We're adding a constant to the variable p, so that variable is not isolated. Third, 3m equals 7. Is the m isolated? Nope, it's being multiplied by 3. We need a coefficient of 1, or no coefficient showing at all, in order to consider that variable isolated. You can isolate a variable using the properties of equality and inverse operations. An inverse operation undoes another operation. For example, subtraction is the inverse of addition. When you solve an equation, each inverse operation you perform should produce a simpler equivalent equation. Problem 1. Solving an equation using subtraction. What is the solution of x plus 13 equals 27? Well, consider what you might think on the left and what you may write on the right as you solve this problem. First, think you need to isolate x. So start by writing the equation, and then write the equation. X plus 13 equals 27. Next, think undo addition by subtracting the same number from each side. So this is an example of an inverse operation. Write x plus 13 minus 13 equals 27 minus 13. Then think simplify each side of the equation and simplify. X plus 13 minus 13 is just x, and 27 minus 13 is 14. Finally, think, substitute your answer into the original equation to check it, and do that. Our original equation, x plus 13 equals 27. When we substitute 14 for x, 14 plus 13, does that equal 27? Yes, it does. So our solution, x equals 14, checks out. Your turn, part A. What is the solution of y plus 2 equals negative 6? Check your answer. And part B, a reasoning item. In problem 1, why does subtracting 13 from both sides of the original equation result in an equivalent equation?